Swayam Prabha. Digital India. Educated India.
So far, we have seen the four elements of the supply chain ecosystem for a global supply chain. Now, one of the important aspects of the analysis is the performance analysis of the supply chains. So, it's important how each of these four elements contributes towards the performance of the supply chain. For example, the performance means we are looking at lead time, cost, and so on. How does given a supply chain and the factors, how does the institutions, that is the government policies in various countries where the suppliers and the assemblers and the logistics providers are located, and also the delivery, the roads, the infrastructure, and the third party logistics providers and the resources, their expensiveness, will all contribute towards the performance. So this is where this becomes an important part of the ecosystem management. So we'll say, what is the global supply chain performance? We'll first mention the elements, and then look at the lead time, and then the cost, and look at the performance measures and the ecosystem. As I told you before, that the ecosystem, the four elements, have several decision makers. In other words, if you take the institution, the government is the decision maker if you want to change the policies to make the supply, to make the institutions more favorable towards the supply chain performance. And similarly, if you are looking at the resources, if you are looking at the delivery infrastructure, then the corresponding decision makers need to be responsible for the supply chain performance. So that's where the performance measures and the ecosystem is an important thing. This is the global supply chain which we have, where the important thing is the suppliers are in countries like China and India, which forms the tail end of the supply chain, whereas the demand or the retailers are in the US, UK, and so on. So basically, the intermediaries, like the transport hubs, the manufacturing and distribution, everything is in between these two countries. So the goods travel, as we have seen, from the tail end of the supply chain to the head of the supply chain where the demand is there. So what are the performance measures that we have? One of the performance measures is the lead time. What is lead time? The definition of lead time of any process is in the interval between the start and end of the process. So now here, if you take a supply chain, there are various lead times that are involved. If you take the entire supply chain, it is from the start of the manufacture from the suppliers, from the raw materials, till the product is delivered to the customer. So if you make an automobile, the entire lead time could be from the mining of the iron ore till the end, the car is finally delivered to the customers by the dealers. This is where Henry Ford used to say he want to mine on a Monday morning and then deliver the car, which is made out of the same steel, on Thursday evening, and collect the money on Friday morning. So this is the kind of vision that Henry Ford has, that because his company was vertically integrated. He has owned iron mines to the ships, to the factories, to make the cars and so on. So, but once he sells it to the dealership, he collected the money. So he was basically saying that 4 or 5 days is the lead time, that the interval from between the start and end of the process. But nowadays it is with a globally dispersed this one. You have if this is the supply chain lead time, you can have the lead time between the manufacturers and the distributors. Now, for example, if what Dell does is, if you pay by Dell today, and they will say they'll deliver you within 24 hours. The order goes to a manufacturer, he assembles the PC, and it is given to an express service provider, and it is delivered to your house. So that is the lead time, but it is not the entire lead time. It's the delivery time to assembly and the delivery time for transporting it to the customer. But whatever is the time, you have to define the appropriate time interval between the start and business of the processes, where you want to minimize the lead time. Reducing the lead time basically frees resources, reduces the cost, and improves quality. Why does reduction in lead time improve the quality? That's because if you are doing everything going well and you are able to assemble the products correctly, that means you have high quality products with you, and the final assembled product is of high quality. And it also frees resources. Instead of taking 2 hours, if you finish it in 1 hour, then you have all the resources which are freed for 1 hour. And similarly, you are reducing the cost because of these factors. Now, what about the cost? Now, in a global supply chain, there are various costs that are involved. There is, of course, the unit cost, the cost of the material and the product. There are costs involved in transportation and storage, because the components have to travel from the supplier to the assembler, and they in between they could be in some warehouse, and it has to be definitely transported by trucks and ships and so on. So there is cost involved there, and also the customs. There is the insurance, because when the products travel, there is necessarily insurance. There are financial services. The banks provide the financial services, but they are not free, but they have their own margins. And there are negotiations. There are people who are talking to the banks to do the business for you. They are talking to the insurance to do the business. They are talking to the customers for facilitating the transport of goods easily. So all this basically is negotiations. Negotiations are expensive. And also inspection, damage, theft, obsolescence, etc. If you are not able to sell the product and it becomes obsolete, then you have to throw it away. So basically obsolescence is another cost. Strategies for cost reduction are important. So what does the lead time and cost are important in the sense, if you have a product, you should sell it to the customer immediately. Otherwise, you have all kinds of costs. Now, depending on where your customer is, you incur a lot of other costs like transport, customs, the insurance, and so on. So basically, one has to be carefully measure or carefully understand the implications of lead time and cost. There are other parameters. One is, the important thing is quality. Managing all the work processes so that each is on target and the entire process is on target with low variability. Basically, if you say this particular product, it should take only 1 week, and it should be next week, it should be delivered, for whatever reasons, all the work processes should be on target, seen to be on target, so that the entire process has less variability. Variability induces other uncertainties, and it will improve the inventory levels. Another thing is the flexibility of the supply chain. It's the ability to meet customer demands under uncertainties of various dimensions. For example, delivery time. Somebody may want it in 24 hours, 48 hours, next week, and so on. Delivery schedules and ordered quantities. Somebody may say small shipments. So he wants it on a Monday morning, or he wants several shipments of small quantities. design, demand, and product mix changes. So there are several kinds of things that different customers may measure depending on their convenience, ask from the manufacturers. So you should be able to provide flexibility for all this. This is usually measured in terms of product variety manufactured and delivered, changeover times between products, time interval between the successive new product introductions. So this the delivery, the flexibility is an important issue, but the supply chain sometimes may not be able to but it meet all the requirements. It may have a menu of items. For example, companies like Dell, they produce PCs of various quantities, but they have a menu, they have a sheet based on which you can order and you will be delivered, a menu sheet from which you can choose. But some companies may have more flexibility in terms of this, but it is important to note that the flexibility costs money. More flexibility means more work, more coordination and all that. But in this lecture, we are going to look at only first two of the performance measures. One is the lead time and the other one is the cost. So then the other things we'll leave it to the reader to figure out. So what is lead time? Lead time is you map the entire process, highlighting the sub processes, interfaces, decision making points, etc. What happens here? You have the supply chain, you have the suppliers, the manufacturing, and then from suppliers to the transporting the goods, from supplier to manufacturers and so on. And you have a supplier, the logistics provider and the manufacturer, and there is an interface between the supplier and the logistics provider and the logistics provider and this one. This interface means it's basically a coordination issue. So this interface is smooth, everything is fine, then the lead times are low. If the interface are rough, in other words, one doesn't talk to each other, or there are misunderstandings about the delivery and other things, and the messages won't reach properly, then there could be lead time should be higher. And also there are decision making points at each level. Now, for example, if you say the shipment is ready, but somebody has to say, you take this shipment and deliver it to somebody. So there's decision making points. Things has to be carefully. This one, they also determine the delays that are involved. So the interval between the start and end of a process, it depends on the context. For example, if it is new product, the lead time is concept to market time. In other words, from the time you decided to produce this particular product to the time it is in the market for the use by the customers. There is what is called order to delivery process. For example, in case of Dell and others, is the delivery time. In other words, once you receive the order, if it is in the warehouse, you supply it immediately. If it is not in the warehouse, you assemble it and supply it. So if it is, you have to manufacture, then if it is from order like furniture, once you get the design, you manufacture it, then assemble the whole thing and deliver it. So the delivery time depends on the order to delivery and so on. The supply chain process, it is the procurement to retail. And if it is B2B process, it is warehouse to warehouse. It is B2C process, it can be warehouse to consumer. So the point I am making here is that you have to be carefully define your process and its beginning and the end, and also who are the people who are involved and what are the interfaces, what are the decision making points. Then it is easy to get the lead time. Lead time includes quality and cost. Low lead time, that means no defects, and less resources, so the cost is less. If you have more time, more lead time, that means you are using more resources, it means more cost. So, if you look at the supply chain lead time, the lead times are longer in global supply chains because of the transport delays and customs procedures at the ports. And lead time is important for perishable goods. Supposing you take this particular diagram, from the raw material, they are the suppliers, and these are the interfaces between the supplier and the transport, and these are the interfaces between the transport and the manufacturers, and then to the distribution and to the retailer through the customer and so on. So, if you are talking of the network lead time, this is the network lead time. Now, there are the suppliers, their manufacturing time and their loading times here, and the logistics this one, and of course, this is the transport time, and this is the manufacturing assembly time, and again transport time and distribution time, and at every place there are decision makers and their decision making time, and overall there is a coordinator, and their coordinator, it all becomes this one. So, it's basically, if you have a global supply chain compared to a local supply chain, where from the supplier it goes directly to the manufacturer without this transport, if it doesn't cross countries, then of course it is simpler. You are skipping the customs at the ports and so on. So, basically the lead times are shorter. Lead time is an important, if you are talking of food, fashion and electronic products. Well, the technology changes in electronics is very fast. So, there for example, as you can see that there were PCs, from PCs we have laptops, from laptop to tablets to cell phones. So, the technology is changing very fast. So, because of that, if you have an electronic product, it takes 6 months to deliver, then the product is outdated by the time it is delivered. And similarly, food is time sensitive. It has to be temperature sensitive. So, if today's food it is delivered after 2 days, then it becomes spoiled. And similarly, fashion clothes. So, fashions change. So, you have to deliver them fast within weeks. So, the supply chain lead time, it all depends here. If you have it in the distribution center delivered to the customer, that is the delivery time here. But on the other hand, if you are assembling and transporting and distributing, this is the lead time. But if you are starting here, and that becomes the supply chain network lead time. So, the lead time difference. So, but it is important to note that lead time is a very, very important measure, and one has to carefully measure and minimize the lead time. So, if you want to get the components of this, what are the components of the lead time? One is procurement lead time. That is the time that is required for the supplier selection based on time, cost and priority considerations. So, if you have a particular product you want to assemble, you have to basically choose the suppliers, and the supplier, once he receives the order, he has to manufacture and deliver it to you and through a logistics provider. So, it involves both the logistics time, the delivery time as well as the manufacturing time, in addition to the selection, the supplier selection and other priorities. So, it depends on the supplier's capacity to deliver things on time, because his manufacturing capability and capacity should be consistent with your order. The second time is the supplier lead time, the time elapsed from the time the order is received till the component is ready for delivery at the supplier. And then the inbound logistics, the time required for the components or subassemblies to reach the supply hub near the factory. It's the maximum of the delivery times for various suppliers and includes the passage through international ports. So, if you are a manufacturer and you are maintaining a supply hub before your factory, then you have several suppliers located in different countries, and all of them, all the components need to arrive for you to assemble. So, that's where the the maximum, the delivery times are the maximum of all the delivery times. Supposing one component 1 comes in 1 week, component 2 comes in 3 days, component 3 comes in 2 weeks. So, although the other 2 have come, 1 and 2 have come earlier, the component 3 takes priority, because you cannot do the assembly for 2 weeks. So, other things have to wait on this. So, if it is the maximum of delivery times from various suppliers and includes the passage to international supply. There is the assembly time. Assembly time is time required for assembly, testing, packaging and final delivery to the distributors. And of course, outbound logistics, the time that is required for various sub-assemblies to reach the consumer site after customization. So, these are the 5 components of the lead time. Other 2 components are the customs and trade facilitation, time taken by the customs for processing the shipment at various ports, that the components and final product visits, and there is of course the coordination time required for choosing the partners for a particular order, and quantity, quality and exception management. Well, these are basically the 7 components of the time, and you have to add all this to complete location. So, when you are basically want to minimize the time, location of facilities in several countries will certainly increase the complexity of coordination, scheduling, transportation and in transit inventory. I mean, there is no doubt that global supply chains are more longer and they have to carry more inventory than the local supply chains. So, if you are looking for the cost advantages of the global versus this one, the low cost advantage may disappear. Uncertain lead times will increase the inventory levels, political uncertainties and differences in culture further exacerbate problems. So, if you have take the raw material supplies, transportation, manufacturing, distribution, and if you assume everything is normal, then you can write the supply chain capability or supply chain lead times, and you can find out find the limits LSL and USL, and if they are not within the limits, you can always try to improve the supply chain capability. More variance of the delivery time requires longer buffer stocks to meet the demand. Variability reduction is a common objective. So, in the supply chain lead times. So, if you take for example a garment supply chain, like for example you have the fiber manufacturer who is takes 10 weeks, and you have cotton spinning which takes 12 weeks, and the transportation takes 4 weeks, and here transportation 3 weeks. So, which actually means that this is the maximum of 10 plus 4 and 12 plus 3, which is 15, and this textile mills take 12 weeks, and garment manufacturer takes 8 weeks, and there is 5 weeks of transportation time, and there are 2 weeks of the transportation time to the distributors, and distributor takes 6 weeks, and there is 1 week to the retailers. So, you take actually the lead time becomes 50 weeks. Yes. So, what you can see is here in the garment supply chain, if you just leave it to the to itself, the supply chain, then it takes almost like 50 weeks, which is like 1 year from end to end. And the garments are fashion intensive. So, if the retailer here, who is a big retailer say in the US, he has to order 1 week before, 1 year before for making the orders, that becomes a big issue in terms of management of various factors. But if you take some of the more recent orchestrators like Li and Feng or something, they take only 6 weeks from end to end. So if you can coordinate well, you can reduce these 50 weeks to almost like 6 to 8 weeks. So that basically depends on the same, but it depends on the architecture and the governance mechanisms that you use to reduce your supply chain, and also the coordination costs. So let's look at the cost here. So what is the total landed cost that is involved in this? The total landed cost is the unit cost, that is the raw materials and the component costs, and inbound logistics cost, cost of moving materials and components to the factory site and from suppliers located in different countries. And the third one is the assembly cost. This includes labor, assembly and equipment costs such as molds and other asset specific instruments. And of course, there are the customs duties and taxes, and there are inventory costs, raw materials, work in process, finished good inventories. And outbound logistics cost, the transportation costs include supplier to low cost country port, LCC port to domestic port to distribution centers, pick and pack operations at the distribution centers and plants, and distribution center to the customers. So basically you have these 6 components of the costs. You can include the brokerage and other costs if you want to. Coordination costs, which is the inspection cost, managing the relationships with the companies in different time zones, culture and languages, IT, administrative and legal functions. So it's not just the unit cost. Usually people think, oh, it is cheaper if you take just the unit cost. But what about all this? There are the transportation costs, coordination costs, there are the inventory costs and customs duties and others and so on. So one has to carefully assess when you are doing a global supply chain, when you're dealing with a global supply chain, you have to carefully assess the total landed cost in this. So if you look at the transport costs, the transaction costs which are there, and that is the supply chain, which is the production, quality and transport costs that belong to the supply chain. And you have the delivery costs, delivery, shipping, inventory, asset specific, hard and soft infrastructure. Here I have used the word asset specific. Asset specificity depends on the particular component that you are involved. In other words, if supposing you are transporting the equipment like boilers, which is a huge equipment for oil and gas furnaces or something, then these are made in one country and need to be transported to the other country, of course by ships. But these have to be dismantled first, and they have to, because they don't go into the ship and they cannot come on the trucks, they have to be dismantled. You require special equipment, special trucks to load them onto this, and then you have to basically assemble at the other end of this. So basically shipping is not just taking the components, like if it is a PC, you just pack it, put it in a box and then put it into the container or into the aircraft or something. But there are the transport could be highly asset specific. If you are transporting a car, for example, you have to have a special truck for that, and the special truck has to come empty while coming back from the after delivery of the particular car. Supposing in India, if the Maruti cars come from somewhere in Delhi to the south, then after coming back, these huge trucks which are used only for delivering cars, they have to go back empty. So that's where the delivery mechanisms become highly asset specific. And also there is the hard and soft infrastructure that is needed in the delivery mechanisms. That's because it's not always the trucks. You have to basically carry the documents, you have to also carry the insurance and other issues. So the logistics companies or the delivery, this one has to have, there could be highly asset specific equipment you may need, and also depending on the insurance and others, you need to have coordination with others in this. Then there are resources. For example, depending on the particular product you are doing, resources could be asset specific. That is, the clusters, you may require human resources who are basically, if you are in R&D, you require PhDs who are doing this. If you are in, say, IT, this one, then you had require trained IT professionals in this. And if it is, of course, financial, you require and power, etc. So the resources that are there could be sometimes asset specific. Human resources could be asset specific, clusters could be asset specific, and also the power requirements could be huge if depending on the particular industry you have. For example, if you have a cement industry, then the kind of fuel that you require could be highly asset specific. So, and then finally you have the institutions, taxes, tariffs, and special economic zones, free trade agreements, and also social groups. Social groups come in here because it depends on the industry. If the industry has a lot of GHG, greenhouse gases, which are coming out, or sulfur, or if it basically gives into a lot of pollutants into the water and into the ground, then the social groups may have the problems associated with this. So whatever issues that we have considered in the cost, we have put them all here. These are called transaction costs. Now, there is a theory that when do you outsource a particular activity outside? You outside, if the transaction cost of the cost of doing it locally inside the factory or inside your company is more than what it is done outside. So if you can actually use this particular diagram to find out the supplier. Supposing you want to make a decision, do you want to make a particular automobile product within your company, or you want to outsource? Outsource to where? Outsource to China, outsource within the local company, local in India or within the US, wherever you are. Now, you go have an Excel sheet and find out all the costs that are associated using this particular diagram here. And you have to add one more, that is the coordination costs, which is the broker fees. So if you add all this, which is the transaction cost, then you can use this one for the selection of suppliers. In other words, if you want to select suppliers for a particular component, and you can use optimization problems to minimize the total cost associated with this, or you can use this transaction cost, which if you have all this data that is available, it's easy to compute the transaction cost and make a choice between one supplier in one country to another supplier in another country. And also you can add the risk costs. Supposing depending on the governments, depending on the location of the country, there could be more financial and other risks for the supplier may face. So you may want to minimize both the transaction cost as well as the risk proficiency. So some of these could be obtained as data, some of these could be subjective information like good, bad or ugly or something. Then you can use all this to basically use this transaction cost to determine the supplier selection or in your analysis. So far about the cost, lead time as well as the cost associated with this. Now, I have shown you in terms of the cost as well as the lead times, how various ecosystem elements contribute towards both the lead time and cost. Let me put it all together and write it into what are called ecosystem enablers. So, here the nation's economic and import and export policies such as tariffs, customs regulations, free trade agreements and the logistics infrastructure highly influence the growth of the firm and the industry vertical. I think this is something which we have already talked about. These enablers are features of the ecosystem elements that influence the competitiveness. Enablers are vertical dependent and include both hard infrastructure as well as soft infrastructure which implements the regulations. As I said before, if you have a vertical, say oil and gas, then the kind of infrastructure that you need, the kinds of rules and regulations that you have, the kinds of resources that you need are different from if you are talking of an electronic vertical or an apparel vertical or textile, this one. So, or a food vertical. So, the issues, one should understand that these enablers are vertical dependent. And lead time or cost are dependent on all the four elements of the supply chain ecosystem. And they are both soft and hard enabling features. This is one thing that people have to realize, that if you are doing a supply chain performance analysis, just based on the supply chain, this one, using queuing theory or using any other methods, which is standard methods which are available in the literature or Markov chains, then you will be making a big mistake if you don't include all the four elements of this. What happens at your ports, and how does your regulations affect your lead time, and how does the availability of the human labor, available human labor productivity, how does it affect your costs, how does it affect your lead times and so on. So, it becomes very important to analyze this. So, let us do some soft analysis of this. So, here I have an example of the so-called enablers. In other words, I have the supply chain, delivery services, institutions and resources. These are the four elements of my supply chain ecosystem. Now, what are the enablers? Now, I am talking of a general or a generic supply chain. Modular products, just in time, total quality management, supplier relations management, supply chain visibility and collaboration. Well, all of us know that if you have these are all good things that a supply chain can have, and they become enablers. Enablers for what? Enablers for reducing the lead time, for reducing the cost and so on. And what are the enablers for delivery time? Enablers meaning they are good features which will enable this particular, you call this is a good service. For example, delivery services, connectivity between two places, the ports, roads and IT infrastructure, third party logistics providers, software vendors and all that. These are all the enabling factors that you look for if I am looking for a delivery services. And similarly, what about institutions? What do you look for? The governments and social groups? Free trade agreements, customs duties, foreign exchange regulations, intellectual property and legal systems, and trade facilitation and so on. Because when I am importing or exporting from a particular country, I want to look at the business friendliness here. So, that is where I look at the institutions. And of course, I look at the resources, natural resources, power, clusters, finance, R&D, labor productivity and management skills. Well, what I have here are some of these things. You can add depending on the vertical you have, depending on the knowledge you have, depending on your situation, you can add or subtract some of these enablers. Now, if I have all these enablers, what happens to my lead time? In the supply chain, I have all good things, so my lead time will be low. In the delivery services, I have connectivity, ports, IT infrastructure and all that, and I have 3PLs who will do an excellent job. So, my delivery services will be low. And I have institutions who, good customs, good legal system, good trade facilitation, then my lead time is low. I have all the resources that I need. I get the finance, everything is efficient. My lead time is low. So, what I have here is all the enabling factors that are needed for a good supply chain. I have put, and my lead times are low. But supposing, I have, for example, finance problems. And in other words, to get an LC, it takes 1 week. Then, the resources here, then the slow becomes medium. And similarly, if the customs takes 8 days for clearance, then you will have a problem here. So, these are all the enablers which are good features of the supply chain. I mean, of course, this depends. Supposing you are talking of a green supply chain, then these could be different. We'll be doing in the future classes. And the lead time is low if everything is good, and depending on the actual situation, you can actually have an Excel sheet, rank order them and find out what is the lead time. And if you are comparing two suppliers for their lead time, and depending on the countries there are, you can basically get an idea of what the lead time is going to be depending on these factors. You can actually give scores for each of these factors for this for a particular country, and depending on that evaluate the supplier this one. Well, it is the same thing with cost. If you have a modular product, then the high product design cost, well, and then low production cost, because production is just assembly of standardized components, and but in the other hand, you have to the integrated product design is cheaper than modular product design. That's the assumption in saying high product design cost. And similarly, in terms of the delivery services, if you have everything good, then low transportation and inventory costs. Because if you have high connectivity and good delivery services, then your lead time is low, so inventory is low, and low tariffs and high profits is with the institutions you have, and low factor costs if you have all these good things here. So, your cost is going to be low. But on the other hand, if your finance is expensive, whatever loans you take, your LC is expensive, then this goes up. And similarly, if your custom duties are high, then this goes up. So, basically you can compare using this particular diagram very easily using an Excel sheet, the suppliers between two places and a particular choice. This is basically the transaction cost diagram that I have shown, and that can be used for optimizing or selection of suppliers or any of the other players and so on. And similarly, the quality. High quality products, if the supply chain has high quality products, because it has all these features, and high supply chain service levels and market reach, if you have the delivery services of this, and institutions high supply chain service levels, because all the institutions are trustworthy and good, and in terms of resources, high management quality, because you have all these resources which are available and their management skills associated. Similarly, flexibility, product configurations and cost. You can supply various configurations of products, so there is flexibility. There is delivery service to global customers, because your delivery services are good, and supply and market globally, that is the institutions, and the resources are multinational sourcing and management, it becomes possible. And because of the flexibility increases because of multinational sources and so on. So you can also, the flexibility in terms of institutions is because you can supply and market globally. So what this diagram shows is that the performance, which is usually done using mathematical techniques, can be easily translated. How the ecosystem parameters affect the performance, and this is a very, very good diagram. I think you can make an Excel sheet and use it. So what is competitiveness and ecosystem? No country can be competitive in all verticals. I think people should realize that, and the biggest decision any country can make, what are the verticals in which I want to be competitive and which will produce employment to my people, and it will make my country globally competitive, and others dependent on my country. Countries need to build hard and soft infrastructure and make policies and regulations to improve the investment climate for verticals they want to nurture. So, for example, everybody says, oh, you build the ports, you build the roads and so on, but what is the return on the investment for these particular roads? So, roads are important for people to commute, but commuting roads are different from the roads for business trucks to go this one. So basically what one should see is to improve the lead times as well as the costs. So if you make appropriate policies, you can improve the competitiveness of these verticals. Well, you have various kinds of competitiveness, national to firm competitiveness measures. You have country competitiveness, you have regional competitiveness, vertical industry and firm level. For example, in logistics and IT, delivery infrastructure, institutions are customs and trade, and resources are resources management, and that improves the country competitiveness. For example, you may have resources, but you don't know how to manage. In other words, you may have an agricultural land, but you don't know how to use that to produce the food. So that's the kind of resource management skills becomes an important from the point of view of the country, any country. But on the other hand, you may not have resources, but you may have resource management skills. So you can import the resources. If you don't have oil, you can import oil and have an oil factory, a petroleum refinery, which you can sell and make money. So the management is an important factor in this. And similarly, at the firm level, you have firm, logistics and IT partners. That is for the logistics and IT, and companies ties with the government and social groups. This becomes important with this one, that is called the social capital, and the resources, relationships with banks, R&D and other vertical members. So if you are a company, what are your resources in this? And the resources can, as we said, it can be soft skills or it can be strong ties. So that's where I think the firm's competitiveness, this one. If you are an orchestrator, you may not own any resources, but if you have good relationship with people, and if somebody wants to be done something depending on the designs, you try to outsource it to various people and coordinate the relationships, and you can deliver the product to the customer. This is called orchestration, which we will do later. And similarly, the regional competitiveness, vertical industry competitiveness are all depend on this one. Let's look at the vertical industry. Vertical industry specific logistics and IT infrastructure. If you say India is a small hub, is a small car hub, then you should have those specific logistics for transport of components, for transport of this one, and IT infrastructure, ERP and other packages. Industry promotion incentives, like for example in the IT case, India has generated this one, given lot of stops to IT companies as free trade zones and SEZs and so on. And resources is vertical and industry specific resources and skills like human resources, banks, loans, and then the other kinds of industry clusters for the vertical industry. So it all depends on planning. This gives you an idea of how to plan a vertical industry. As I said, no country can be very good in all industry verticals, but it's important that the country has to first choose what is the vertical it wants to be competitive and appropriately develop all the instruments for this from the supply chain. So basically to conclude here, it says this chapter brings to focus the relationship between conventional performance measures and the ecosystem enablers. So we have defined the lead time and we said what are the components of the lead time, and more importantly we have shown how each of these components of the lead time are influenced by the ecosystem parameters. Because each of these ecosystem parameters, if you want say logistics, then there are logistics providers. If you want some policy making, then there you have to approach the government. They are the decision makers, and that's how the performance can be improved. And one can perform the analysis using Markov chains, queuing networks, etc. by mapping the end-to-end delivery process. So you can basically take an example of the end-to-end supply chain and write a basic queuing network, how your product is traveling through the entire supply chain. And if you're at the port, then your container is waiting for clearance, then you are waiting in the queue, right? If your container is on a truck, then the truck is on the road, then you are waiting in the queue. So you can basically write a queuing network for the entire global supply chain and find out it can be an arbitrary general queuing network, or it may have special features like closed queues or whatever. It depends on the particular problem that you have. And you can also write the Markov chains for this and from the end-to-end delivery process and calculate the lead times. You could do system dynamic simulations for this. Once you do system simulation dynamics, you could do sensitivity analysis of if you change the policies, how does your lead time is affected. If you choose some other, instead of air transport, you choose shipping transport, how does it cost affect? How does your lead times affect? So if you choose instead of one country, another country, instead of sourcing from a Chinese supplier, if you choose from a Vietnamese supplier, how does your lead times and other things change? So basically one can find out, do this analysis either by simulation, Markov chains or queuings, etc., by mapping the end-to-end delivery. Whatever we have done for earlier in manufacturing supply chains, we could do this using this chapter, this particular lecture material. You could do analytical analysis. You can use AHP. If you don't have data, if you have subjective data, like say the institutions are good, the institutions are bad, and so on. So you can give scores for those institutions. You may not have to have data on this. Then you can use analytical hierarchy process to get this one. So location selection, supplier selection problems can also be solved using analytical hierarchy process. So to conclude this chapter, this is an important chapter in the sense you have basically related the supply chain ecosystem to the conventional performance analysis that is conducted in manufacturing networks and supply chain networks using Markov chains, then queuing networks, analytical hierarchy process, or simulation. So you could do all that, but in the global supply chain, you can find out to study the sensitivity analysis of how your lead times, cost, and other factors, the supply chain performance changes with the countries making different rules, with the ports you are entering and their trade facilitation issues and so on. So, there are a lot of sensitivity analysis that you can conduct. Thank you.